Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 3 of lesson number 8, motions, right? So as we have already started studying about motion, we discussed on the basic term in part 1. Then in part 2 we have discussed on what is motion, what are the different examples of it. Then there was an activity that we discussed. Then even we discussed on uniform and non-uniform motion. In short, we will be studying it properly and thoroughly today. But I hope whatever we have discussed till now, till this part, okay, you are very much clear with it. So before I proceed with the further part for the lesson, we will be starting with uniform and non-uniform motion today. I hope every one of you have revised it. If not, I want and I hope you all are taking the notes wherever I say that you need to take a note of it, because whatever you're taking a note of is going to help you at the end, when you'll be having your exam. You can consider it to be before exam notes, which is going to help you to be very quick with your revision and all the important points at one place. Okay, so whatever I dictate or whatever I tell you to write, please make sure every one of you take a note of it. And now, as I said, before I proceed with uniform and non-uniform motion in detail, I want each one of you to please revise everything that you have written in your book, and please be quick with it, everyone. I hope every one of you are revising whatever notes you have taken in your book. So now I'm going to show you all the slides one by one, and I want each one of you to please go through it quickly. So we started the lesson by discussing on describing motion. Here we have the most important part which has been given, so I want you all to please be quick with it. I hope every one of you are going through it. After this, we discussed on motion along a straight line. So I want you all to please go through it quickly. After this, after discussing on motion along a straight line, we have discussed on this activity as well, right? So I want you all to like let yourself know the observation, explanation and conclusion for this. I hope every one of you are able to explain the observation explanation for this activity. After this, we again had this activity 8.2. So I want you all to do it quickly as well. After this, we now have to discuss on uniform motion and non-uniform motion. Okay, so see, what is uniform motion? When I am like moving straight, okay, the type of motion in which the object travels with uniform speed. Like suppose I'm driving a car and I have maintained the speed of 40. I'm not increasing my speed. Okay, I'm like driving my car at a constant, at a uniform speed, and that is 40. So that type of motion is called as uniform motion. Okay, what will you state? The type of motion in which the object travels with a uniform speed, that becomes uniform motion. Now if you can see the picture given, at 0 meter 2 seconds, and like the car has traveled 12 meters and it took 2 seconds to the car to travel it, it means it is traveling the same distance, or it is like traveling with a different distance. Like if you can see from 0 to 4 meters, for traveling that the car required 2 seconds, and 4 to 8 it again required 2 seconds, 8 to 12 2 seconds. It means it is maintaining a constant speed, right? So this type of motion we call it as uniform motion. So this means that velocity of the body remains constant as it covers equal distance in equal interval of time, right? The velocity of the body is constant, and how can we state that? Because the car is like covering equal distance in equal interval of time. Okay, then in the case of uniform rectilinear motion, acceleration of the body will be zero. Okay, in case of what? Uniform rectilinear means it's in linear motion, uniform motion. Then in that case, the acceleration of the body is going to be zero, and the average speed of the object will be equal to the actual speed. Okay, what will happen over here? The average speed of the object will be equal to the actual speed, and the example of uniform motion are movement of hands of a clock, rotation and revolution of the earth. Okay, now rotation and revolution of the earth is again an example of motion taking place, right? But what kind of motion it is? It is uniform motion. Okay, so I want you all to draw the picture just for your understanding, and write some a few points with respect to. Okay, I hope every one of you are taking a note of it. I hope you all are going through it. After this, we have like non-uniform motions. So see, the type of motion in which the object travels with a varied speed is called non-uniform motion. Now you have to compare both the pictures. Okay, in that picture, like it took the car from like to travel from 0 meter to 4 meter, it took 2 seconds. From 4 meter to 8 meter, it again took 2 seconds. But from 8 meter to 12 meters, it took 2 seconds, and then 12 to 16, 2 seconds. Okay, so the total distance that they have traveled is 16 meters, and the time taken is 8 seconds, right? So 16 meters in 8 seconds, and over here, it took 12 meters in 6 seconds, right? So over here, when the car is traveling with a varied speed, now the speed has changed. When the car started, it was at 20, then at 4 meters it went to 30, 35, at 12 it went to 55. So when the speed keeps on changing, we know that type of motion as non-uniform motion. Okay, this means that the object does not cover equal distance in equal time interval. Okay, okay, So if the motion is not consistent in the case of rectilinear motion, the acceleration of the body will be non-zero. Okay, in this case, what in rectilinear motion, when the motion is not consistent, and that is the case of rectilinear motion, then the acceleration of the body will be non-zero. Over here we studied that the in case of uniform rectilinear motion, the acceleration of the body was zero, right? What was there? Acceleration of the body was zero. But over here, the acceleration of the body will be non-zero in case of rectilinear motion. Now, for example, motion of a vehicle and oscillation of a pendulum. Suppose you have a pendulum. I'll just show you. Uh, Suppose you have a pendulum which is with tied to a thread, and when you push it, okay, what happens? The pendulum keeps moving from one place to other, right? So that is, in that case also, it is not uniform. Okay, so that is also an example. Oscillation of a pendulum is also an example of non-uniform motion, and non-uniform motion is also called accelerated motion. What do we call it as? Okay, so this non-uniform motion is also called as accelerated motion. So I want you to take a note of whatever points you have, like is there on the screen, like writing about the rectilinear motion, how the movement, how the acceleration will be, will it be zero, non-zero? Okay, all this thing I want you to write in your book. I hope every one of you are writing it. I hope everyone is writing these points in your book. And even what you can do is you can differentiate between uniform and non-uniform motion and write it. After this, we have again an activity, that is activity 8.3. So see, the data regarding the motion of two different objects A and B are given in table 8.1. So if you can see, the time is given and the distance traveled by object A in meter and distance traveled by object B in meter has been given. So the time is given from 9:30 a.m., 9:45 a.m., 10 a.m., 10:15, 10:30, 10:45 and 11, right? So distance traveled by object A in meter is 9:30 a.m. is 10 meters, and the distance traveled by object B in meter is 12 meter, like 12 meters. Okay. Then at 9:45, after 15 minutes, the distance traveled by object A is 20 meters and the distance traveled by object B is 19 meters. Then at 10 o'clock, exactly after 15 minutes, distance traveled by object A is 30 meters and by object B is 23 meters. So same way they have given over here. So what we need to do is, we need to examine them carefully and state whether the motion of the object is uniform or non-uniform. Okay, so I want you all to do this first and then I'll help you with it. But first you need to try and let me know whether they are like traveling, whether they are in uniform motion or non-uniform motion. But you all have to be quick with it. I hope you all are like trying to find out about the motion, which is uniform and which one is non-uniform. Okay, let me tell you the like activity. The distance traveled by object A is uniform. As you can see, the numbers are so uniform, right? And after every 15 minutes, the you can say object is moving 10 meters, right? So that becomes a uniform motion. And what explanation you can write over here is, here we see that every 15 minutes A travels 10 kilometers always, right? While in case of B, it is irregular. Sometimes B travels 7 kilometers in 15 minutes, while in the next 15 minutes it travels 48 kilometers, right? So this is what explanation you can write over here, and inference that you can give is, the activity wants us to know about uniform and non-uniform speed, and it wants us to show that if a vehicle travels the same distance in same unit of time, the vehicle is in uniform motion. Okay, what the vehicle is in vehicle is in uniform motion. An implication can be, while studying motion, we come into the concept of acceleration. Where do we come? We come into the concept of acceleration, and an object with uniform motion is with zero acceleration, while an object with non-uniform motion is either accelerating or it is decelerating. Okay, so you can just write this explanation, observation, and you can say inference in short. I hope every one of you are writing the explanation and everything. After this activity, now we have like to discuss on how can we measure the rate of motion. So see, look at the situations given in figure 8.2. Now can you see the bowling speed in kilometer per hour that has been indicated as 140, 143, 135, 145, right? Then the other situation is the speed limit, which has been shown as 50 kilometer per hour for a car, and for heavy vehicle it's 40 kilometer per hour, right? So if the bowling speed is 143 kilometer per hour in figure 8.2a, what does it mean? And what do you understand from the signboard in figure 8.2b? So in first picture, if I say the bowling speed is 143 kilometer per hour, okay, so like that has been calculated that the bowling speed was that much, and in the second picture the speed limit has been shown that a car should not like have its speed more than 50 like should not travel 50 kilometer more than 50 kilometer in an hour. That is the minimal speed that they have given, right? And for heavy vehicles should travel only 40 kilometers in an hour, not more than that. So that is the minimal speed that they have to maintain, right? So different objects may take different amounts of time to cover a given distance. Now it's not that every object is going to have to cover like same distance in like same time, right? So some of them move fast and some of them move slowly, and the rate at which object move can be different. Okay, what happens over here, some of the objects, like if I throw a ball, it like the movement of the ball will be more faster as compared to a vehicle, right? So that is why it has been said that the objects move at different pace. Some of them will be fast, some of them will be moving slowly, right? Also different objects can move at different rate, right? There will be different objects who are going to move at different rate, and one of the way of measuring the rate of motion of an object is to find out the distance traveled by the object in unit time. How can we measure the rate of motion of an object? By calculating how much distance is traveled by the object in unit time, and this quantity we refer as speed. What do we refer this quantity as? Speed. Okay, so the SI unit of speed is meter per second. What is the SI unit? Meter per second, and we can represent that by symbol m slash s or ms minus 1 on the top. Now why minus 1? Like if you don't want to write minus 1, you can put a slash in between that indicates per sign. So meter per second or meter per second t. So the other unit for speed includes centimeter per second and kilometer per hour. Okay. So to specify the speed of an object, we require only its magnitude. What do we require? We only require magnitude, and the speed of an object need not to be constant. And in most cases, objects will be in non-uniform motion. What will happen in most of the case, the object will be in non-uniform motion, and you need to know this. Okay, so I just want you all to explain this much in your own words. I hope every one of you are writing it. I hope every one of you are writing from the slide the quantity and the SI units which have been given. I hope every one of you are writing it. After this, now here we have more information on it. See, therefore, we describe the rate of motion of such object in terms of their average speed, because there is like so much difference and there are so many different SI units with respect to seat, right? So that is the reason that instead of going like calculating the speed, we calculate the rate of motion of such object in terms of their average speed. Okay, so the average speed of an object is obtained by dividing the total distance traveled by the total time taken, like how much distance the car has traveled and how much time the car took to travel that distance. So that is going to be our average speed. So what is the formula for calculating the average speed? Average speed is equal to total distance traveled divided by total time taken. Okay, so if an object travels a distance s in time t, then its speed is v. So v is equal to s upon t. V is the speed, s is the distance traveled, and t is the time taken to travel that distance. Okay, so I want you all to write about this average speed as well along with the formula. I hope everyone is writing the formula of average speed and you have even understood what average speed is, right? After this, like, we will be studying on this example, like how to calculate the average speed. So see, an object travels 16 meter in 4 seconds and then another 16 meters in 2 seconds. So this is a uniform speed, right? The vehicle over here is in uniform speed. Now the question is, what is the average speed of the object? So the total distance traveled by the object is 16 meter plus 16 meters, that is equal to 32 meters, right? And the total time it took, so it traveled 16 meters in 4 seconds and again 16 meters in 2 seconds. So 4 plus 2 becomes 6 seconds, right? And now the formula for calculating the average speed is total distance traveled divided by the total time taken to travel it. So the total distance traveled becomes 32 meters divided by total time taken is 6 seconds. So 32 divided by 6, we get the answer as 5.33 meter per second. So therefore the average speed of the object is 5.33 meter per second. Okay. Now in the next class, we will be discussing on speed with direction in detail. Okay, so here also you will understand like how exactly the speed of the object goes along with the direction. Then we will be discussing on activity 8.4, 8.5, and we will be discussing both the activities with proper like the observation, explanation and conclusion. Okay, then after that we have example 8.2 again, which we will be discussing on 8.3, how to calculate the average speed and the average velocity. Then we'll discuss on rate of change of velocity in detail. And after this rate of change of velocity, we'll be discussing on acceleration in detail. Like what is acceleration? Then we have activity 8.6. Then we have example 8.4 which has been given, and over here like the example is related to calculating the acceleration of the bicycle. Okay, so we'll discuss that. Then after that we have graphical representation of motion, how to calculate it. Then we have distance time graph, we have velocity time graph. Now these are very important, you should be knowing it, the distance time graph and velocity time graph. And then we'll discuss on activity 8.7 in detail. After this we have 8.8. Then after this we will be discussing on equations of motion by graphical method. Now this is also very important, studying about the equation of motion by graphical method. Then we'll discuss on equation for velocity time relation. Okay, then equation for position time relation, position velocity relation, we'll be discussing them all in detail. Then we have example 8.5 where we will be calculating the acceleration and the distance traveled by the train for attaining this velocity. Okay, then in this example 8.6 we will be discussing, like we will be calculating acceleration and the distance covered by the car. Then over here also we'll cover the, like we will calculate the distance, and then after that we will be discussing on uniform circular motion, what exactly it is. Okay, then we have activity 8.9, and this is how we will be ending up with the lesson by doing the summary revision. Okay, now after this summary we have like few exercise questions to discuss. So I want each one of you to please go through this exercise question quickly. So this is how we will be ending up with the lesson motion, and I hope whatever we have discussed in this part of the lesson, every one of you are very much clear with it. Now I want each one of you to please revise whatever we have studied today, and then we'll continue with the rest of the part in the next class. Thank you everyone.